Hello, today I'm looking at logging in Metatrader, and this is a request from one of our subscribers, and it's a request for improved logging. So logging that might include a severity level or to be able to write to different log files depending on your expert or symbol and so on. So Metatrader 4 and 5 already have this experts and journal tab, and these are both log files already. So you can write to the experts log file simply by using the print statement. If I right click open, and here are the log files that are being written for the experts already from Metatrader 4. And the same thing for Metatrader 5, they'll just be in the MQL5 folder. But the code I'm going to show you will write to the files folder. Let me go back to here, MQL4 and files, and it will write inside that, and it will write log files with names that you specify. And with this code you'll have more control over the formatting and the content of these log files. And this code will work for both Metatrader 4 and Metatrader 5. I have the editor open now, and I'm going to write the first level of logging. This won't be very different to the logging that you get with the built-in print statement that writes to the experts log, but it will give you some control and possibly have multiple logs depending on your expert advisor. I'm going to write this as a class file, and that way as I build in the more capabilities in version 2, 3 and 4, I can simply inherit from the original class file and not write everything a second, third and fourth time. So because this is an include, I go to the include, orchard, and I'm putting this in the common toolbox. I'm just going to create a folder here called logger. And then I'll create my version 1 under that. So I've opened the file loggerv1.mqh. First thing I'm going to do here is the class statement. And now I've added the basics of the class statement. So class, I'm calling the class C logger v1, and I don't have any values in here at the moment. The only thing I have is the constructor and destructor. Now this is going to write to a file. That means I need to have functions to open the file, to write to that file. And I want to keep the file open in between writes. I don't want to close it each time and reopen it again. So I'm going to need to store some values in between writes to the file. I'm going to put those values in the protected space because when I inherit later I'll need those. So all files opened have a handle, and I'm storing that handle. It's an integer type, so that's going to be a member variable. And then I also have a file name for that log file. I'm just going to create two functions, one to open the file and one to close the file. And these are just the declarations of the functions. They're finishing with a semicolon here. I'll have to write the functions later. And I'm going to create a separate function to give me the name of the file. So these files won't have a fixed name. The name will vary depending on factors such as the symbol and the time frame. So I'm going to have a function that will return the file name for me. And I'm going to have another function that converts the period value, the enum for the period, into a string. So I can simply use enum to string, but that gives something like period underscore h4. I just want the h4 out of that. So this period string will parse that enum for me. And then of course I need to actually write to the log file, so I need a function here that will write, and it will have a message that you'll pass in to write to that log file. So the log open and log close will simply open and close the file. They are of type void, and I've made them virtual so that I can override those in subclasses coming later. File name will return the string for the file name, and that's also virtual. And period string I haven't made virtual because I don't think I need to, but it just returns a string, which is the value of that period. The write will return a boolean whether it's successful or not, and it takes one argument, which is the string to be written out to the log. So in the constructor I need to initialize the handle and the file name. So I'm setting the handle initially to invalid handle, and that just tells me that I don't have an open file. And I'm initializing the file name to an empty string. And then in the destructor, the only thing I'm going to do is close the file if it's already open. And I'll call my log close function for that. I'll start with the file name function because I'm going to need that for the file open. Now, in this initial version of the logger, I'm not giving a lot of options in terms of the name of the file. I'm using the string format function, which simply takes this string with the embedded placeholders and replaces the placeholders with these values in the remainder of the function. So I'm setting the file name to a string format, and these will all go underneath the files folder, so they will be in a subfolder under that called Orchard. I'm using double backslash because a backslash is a special character, so a double backslash equates to a single character, which is the folder delimiter. I'm placing these in a folder called log v1 so that I can see them separated later from those that I create in log v2, 3 and 4. And then here are my placeholders, 3 strings and .csv. It's important to include the extension because that won't be added automatically. And the 3 strings that I'm going to be replacing will be the current chart symbol, that value from the period string function, and the time current just for the date. So this will open a new log file each day as the date changes. I'm using time current, which is the current server time, and your time to string function will convert that to a date in the format YYYY-MM-DD. And then I simply return the file name from that. So now the log close function. No arguments to that. First check, if the handle is an invalid handle, then there is no file to close, so I just return. I'm calling file flush, and that will make sure that anything that has been written out to the file is actually written to the disk. And then just file close for that handle. And at the end of that, I set mhandle to invalid handle so that I know that this file is closed and can't be used. And then just return. And now the log open. First thing to do in opening a file is to make sure there isn't a file already open, so I will call close. And then I want the file name, so I'm calling the file name function for that, and I'm storing that in my mFileName member variable. And then I need to open the file, and the result of file open returns an integer, which I'll put in that member handle variable. And the arguments to this: first argument is the file name, and then all of the flags that I need to open that file. I'm going to be writing to the file, so it's natural that I have the file underscore write, but I also want to move to the end and append to this file if it already exists. And to do that, I also need file read. So it seems odd that I need file read if I'm only writing to the file, but I need that to find the end of the file. File ANSI is mainly for Metatrader 5, but it doesn't hurt to include in Metatrader 4. Metatrader 5 will want to write these files in Unicode, which is fine. They'll still be a comma-separated file, but if you simply open those files with something like Excel, they won't show as comma-separated. They will show as a simple text file. Using this file underscore ANSI flag sets the files to be single byte, and then Excel will open them as a normal CSV file. Now, although I'm writing CSV files, I'm opening them with this file underscore txt. I'm not going to be using the CSV functions of the file write. I'm just going to be writing a single string out, and I'm going to be inserting my own commas into those files. Now, because I'm keeping this file open until I terminate my expert or my indicator or whatever's using this class, and because something else may be using the same file, I'm also including this file share read flag, which means that the file can be opened and read by other experts, and at the same time file share write, so it can be read and written by other applications at the same time. And then I just return. Now if file open failed, then mhandle will have invalid handle, and I'm not testing for that here. I'll be testing that in the functions that call the open function. And now the period string function that just returns a simple string that tells me what the period is for the current chart. So the first thing I use is the enum to string, that takes an argument of type enum underscore timeframes, so I need to cast period because period by default returns an integer. And this enum to string will return a value like period underscore h4. I don't want the period underscore, I only want the h4. So first I'm doing a check. This shouldn't be necessary, but it's just good practice. I'm testing the first 7 characters of the returned value, and if they are period underscore, then I take the remainder of the string, which is also the string substr function, passing in that period that I've got here, beginning at character number 7, and by not filling in the last argument, the default is 0, which takes everything to the end of that string. And then I return period. So this will now only have the characters in this enum value after that underscore. And finally, the write function. So this takes a single argument, which is the message that you want to write to the log file. First thing I'm testing, if the handle is invalid handle, which it will be when we first come in here, or if the file has been closed, or if the previous open failed, or for any number of reasons, then I obviously can't write the log. Or if the file name that I stored in mFilename is not the same value that the filename function returns. And if either of those are true, then I'm going to call the open function. This filename not equal to filename function could happen if we scroll back up to the filename function. One of the arguments in here is time current and converted that to a date. So if we're writing a separate file for each day, as soon as this time date changes over to the, or as soon as time current changes to the next day, we would get a different file name. And if that happens, then I want to open a file again. So I don't want to keep using the existing file that I have open. And remember that calling log open will first call log close, so it will close the file that we had open and then open a new file for the current day. So if the file name has changed, or if the handle is invalid, then we will open a file. And this log open puts a new value into the mHandle variable, and so I then have a second test. If mHandle is still invalid, so if that's equal to invalid underscore handle, then I'll just return false because the write has failed. Now I'm resetting the last error. I'm not going to be doing anything with the error, but I'm resetting it here. You can add your own error handling if you want to do more. The first thing I want to do from here is find the end of the file. So when you first open a file, the pointer is at the beginning of the file, or if we're opening it in a shared mode and something else has been writing to the end of it, we may not be at the end of the file. So the file seek function moves the pointer inside the file. And the arguments to that are the handle, an offset from a position, and that position we're setting is seek underscore end. So we're moving to 0 bytes away from the end of the file. And if that fails, then I'll just return false because I can't write to it if I can't seek the end of the file. And now I'm formatting a line for the output. I said that I wouldn't be using the comma functions of the write. I'm just going to build my own string. And to do this, I'm using the simple string format. I have 4 values in here, so I'm just using the placeholder %s. They're all going to be strings. And I've inserted the commas here that will appear inside the CSV file. And those 4 arguments that I'm going to be writing are the current time, using time to string, and by default this will return the date and the hour and minute for the time. And then the symbol, the period converted to a string, and the message that was passed in. Now, symbol and the period are already in the file name, but the current time, that's only showing as a date, so I guess that's something to add. But I'm just repeating these values inside the file. Doesn't hurt to have them there. So that creates the output that I'm going to be writing to the file. And then I write that with the simple file write function, pass the handle and the value to be written, that line, and that returns an integer. And if that returns a 0, then the write has failed, and so I simply return false. And then I call file flush, which takes all of that data that's been written to the file but may still be in memory and actually writes to the file. And then if I've made it that far, I just return true, which means the write was successful. Let me just do a syntax check compile on that. No errors. Now I'm going to create a script where I can test this. I won't take you through writing the script. I'll just insert it here and then come back. So here in the scripts I've created this logger example v1. I also have an MQ5 version. This code is identical for MQ4 and MQ5, so I've created both the scripts there, but I'll only be demonstrating the MQ4 version. So I just have a simple include statement of orchard common toolbox logger v1.mqh, and then I'm creating an instance clogger v1 asterisk logger, so it's a pointer to an object of type clogger v1, and I'm creating that with the new clogger v1 statement. There are no arguments to the constructor for this, and then I'm simply calling the logger.write function, and the string I'm going to pass in v1 for version 1 default log level message. I might actually duplicate that and write 2 of them. So that will simply call the logger and write these 2 messages into the file. If I go back to Metatrader 4, I can go to File, Open Data Folder, and then inside MQL4, or if you're using MT5, then inside the MQL5, there is a Files folder, and this is currently empty. I'll just leave that there and go back to here. I'll compile that MQ4 file, and then I'll run that, and that has finished. So now if I go back to Windows Explorer, there's the orchard. It has created the folder already for me. Orchard, log v1, AUDUSD, h1, so that was part of the file naming, and the file name also included the date, and that's a CSV file. I don't have Excel installed on this machine, but we can edit that, and I can see that what I've inserted there is date and time, comma, symbol, comma, time frame, and then the message, and I've written 2 lines for that. So let's now look at the next stage with v2. So now I've created a logger v2 file, logger v2, everything's the same, but because I'm going to inherit from logger v1, first I need to include that logger v1.mqh file, and this is just using quotation marks because these 2 files are in the same place. And then my class declaration, class clogger v2, and I'm inheriting, so I have colon public. I want public inheritance from clogger v1. What I'm going to be adding in version 2 is the ability to set that file name using some kind of template. And I'm going to allow you to also insert some values. I'm going to allow you to use the expert and the magic. So the expert would just be a string, and magic would be the magic number, so you can include those in the file name of the log file. And because I'm inheriting from clogger v1, I don't need to recreate any of the functions that are already in clogger v1 unless I change them. And so most of what's in clogger v1 will remain. I will be changing the file name only. Now, because I'm going to allow you to specify the expert and the magic number, I need places to store those, so I'm creating 2 member variables, mexpert and mmagic. And then file format original. I said I'd be allowing you to format or use a template for the name of the file. So this m file name format original will store that original template. And after it's been formatted, or I'm going to do a pre-format on it, let's say, and you'll see that soon. But some of the placeholders you can put in that template won't change because they will be things like the chart symbol, which won't change, where other parts might be the date, which will change. So I'm going to do a pre-format when you first set that. So because the file name function is going to change, I need to declare it here again. So virtual string file name. And because I'm going to be formatting a template, I'm going to create a function for that, which will fill values into the template. I'm creating a second function called format fill fixed, which you'll see, and it will make sense when I show you the function. And then get file name format value, which will be used by the file name function. And apply file name format, which will be used when you reset values like the expert or the magic number. And then public, there's a constructor and a destructor, clogger v2. And because I allow you to set the expert name, I have a function called setExpert and a function for setMagic. and another function that lets you set the template or the format for that file name. I'll start with the constructor and the destructor. In the constructor, I'm going to initialize that expert and magic number. They haven't been set yet because there are functions to call those. So until you set them, the expert name will be an empty string and the magic number will be 0. And I'm going to set a default file name format in case you don't bother to set one. And this is the same as was used in version 1, but here I'm just setting it as a string, and you can see the placeholders that I'm using. I'm using this syntax for placeholders: double bracket, name, and closing double bracket. So the positions that I have here: orchard, log, symbol, period, and date. That's just the default layout. And still nothing in the destructor here. The only thing that was in the destructor in v1, let me scroll up, in clogger v1 I had log close in the destructor. That will still be called when we terminate logger v2 because the destructor of the parent class is also called. And then I have these set functions, so let's write those. So set file name format takes a single string of type format. First thing I do is assign that to the original format. So I said here I have both file name format original and file name format which is pre-formatted. So file name format original is just the value that's passed into the argument here as format. And then I call that other function apply file name format, and we'll see that in a moment. And if you set the expert name, now remember this is a string, so it would be the name of your expert. Very similar, mexpert equals the argument for the function, and then apply file name format. If you set the magic number, it's just a long magic, same thing. I save that in the member variable and call apply file name format. Because these could be part of the format string that you've passed in, so I need to call this apply file name format, which you're about to see, to reset every time you change either of these values. And now the apply file name format function, that file name format, not original, uses this other function format fill fixed and passes that file name format original into that. So that's why I can use this one function, the apply format, whichever of these values has been changed. And we'll see the format fill fixed soon and the format fill function. Now just before we get to those, there is the get file name format value, which actually returns the formatted value name of the file using the templates. And I'm placing this in a separate function to the file name function, simply because if I want to get the file name format for any other reason, I don't need to call the file open function. So first thing I do is grab a string called format here, and that is just file name format, which is this pre-formatted value. And then I call format fill. So remember I have two functions. I have format fill fixed and format fill. So format fill will look for placeholders like this in the string and replace them with real values. And so I'm just returning the value from format fill. And now those calls to the format fill and format fill fixed will make sense now as I write them. I'll start with format fill fixed, and the idea here is that this will replace any of these placeholders that are not expected to change. So symbol won't change, period won't change, but date will change. So all the fixed values can be replaced in here. And that's a very simple call. It accepts a string format, which you can see here is the original file name format. And then it's simply using the string replace function, which searches through this format string, looking for this placeholder, in this case it's symbol, and replaces it with this value, which is the chart symbol. And I simply repeat that then for the other fixed values that could be in the placeholders. So symbol, period, the name of the expert, the value of the magic number, and because these are all strings, I'm using the integer to string to convert this magic number to a string. And those are the only fixed values that I've created placeholders for, but if you have others, then just repeat this syntax. And then the difference with the format fill function is that this replaces things that change over time. And the only placeholders I have here are all related to date and time. But you may want to have placeholders that show things like the opening value of the current bar, or any other value that you might think will change over time. But the syntax is very similar. It still uses string replace in that format, a placeholder, which my default for placeholders is double bracket name, close double bracket. So I'm saying that the date placeholder, DATE, is replaced using the time to string for the current time with time current, and just calling time underscore date. All that does is return as a string value the date portion of the current server time. I have another placeholder that I'm calling date time, and that has a slightly different argument to the time to string. It includes time date, time minutes, and time seconds, and that will return a complete string of date, time, and seconds. And then another placeholder I'm calling time, and does the same thing, but in this case I'm not including time underscore date, so this returns just minutes and seconds. And then I've got the same three repeated, but for the current time local rather than the server time. And the only difference to get the local time is that I'm using this time local function instead of time current. So if you prefer to have your logs using your local computer time rather than the server time, you can use these placeholders. And I've simply called them local date time, and local time. So now that we have the ability to set a template string and set some values being the expert and the magic number, and you can always add more values if you want to. I've just used the expert and magic number. The only thing left is to override the file name function from v1 with a file name function here that will use those templated values. And all I'm doing is calling the get file name format value, and that's this function, get file name format value, which simply uses the format fill to fill in the values from the template. And then I just return that file name. And because that overrides the file name function of v1, all the rest of the functions like open, close, and write will just use this file name function as long as I've created an object of type clogger v2. So to go through that at a high level, when you set the template, the first thing I do is save the original template in this file name format original. Then I call apply file name format, which will simply replace any of the placeholders like symbol and period that I don't expect to change over the life of the logger, and it will replace those and then create a second format template, file name format, which already has these values replaced, and that just saves time on each future call, because then all I have to do is replace these placeholders that can change over time. So that's the logger v2. Let me see if I can do a syntax check on that. No errors there. Now I'm going to create another script to test that. Alright, I've created another script, logger example v2. It's pretty much the same as v1, but here in the include statement I have logger v2 instead of logger v1. I'm declaring my variable as type clogger v2, but the syntax is the same, new clogger v2. Here I'm setting both of those values, the expert and the magic. So I've just made up some names here, a v2 example expert and magic number of 21234. Here is the file name format template that I'm using, orchard log v2, and I've used log v2 here, where you'll remember the default in, well, I'll show you, the default here was just log. So this will show you that I'm actually overriding it by passing this value in, and then my placeholders are going to be symbol, expert in a separate folder, magic in a subfolder under that, and then the file name will be the local date, not the system date, .csv. And then I'm going to call that twice, and I'm going to write v2 default log level message 1 and message 2, and then just delete the logger. Compile and run. Now back to this folder. Here is Orchard, and now it has created this log v2 folder under that. Symbol, expert name, v2 example expert, magic number 21234, and there's the file name 2021.09.04.csv. And if I edit that, here are my two lines, same as the lines that would have been written before. It's got the date and time, symbol, period, and the message. So now version 3 of this, just started a new file again, logger v3. It includes logger v2, which will then include logger v1, because I'm going to be inheriting from the v2 logger when I create logger v3 or C logger v3. What I'm going to add here is the ability to list severity codes in the log and to limit what the log writes by severity. So I'm going to create an enum where I can store these severity values. I'm calling it enum log level. I'm going to have an error level, a warning, information, and debug. You're free to add or remove any levels that you like, but it's important to keep them in order. I'm considering that error is the highest level, and warning, and then information and debug. Remember that enums are just integers, and unless you specify a value, the first value here is going to be 0, and each after that will be 1 more than the value before. So error is going to be a 0, warnings will be 1, information's 2, and debug is 3. And that's going to be important because I'm going to set the level of information, or I'm going to set the level of logging based on where the call fits in this enum. And so then my CLogger v3 class inherits public from CLogger v2. And just like with v2, any functions that are already existing in either CLogger v1 or logger v2 don't need to be repeated here in CLogger v3. So all I need to do here is to write new functions or replaced functions. Now I'm going to let you set the logging level. So you can call any level of logging from your application, but at some point at the beginning, when you set up this class, you simply say which level you want to be logged. And if you set level warning and then make a call with a message of type information, it simply won't be logged. So only warning and above would be set then. Or so only warning and an error would be reported. So I'm going to store that value in mlog level. Now, just like I had get period string earlier, I also have a get log level string, which will turn the log level, which is just an all uppercase enum value here, into a more readable mixed case value. Now I still have a constructor and destructor, but I have to change the write function, or at least create a new write function. And in this case, it takes the message still, but it also includes a log level which defaults to information. And because I have this log level that you can set, I have a function called setLogLevel, and it just takes an enum of that log level. So the constructor here, CLogger v3, v3, and I'm inheriting from CLogger v2. I didn't mention this in the logger v2, but here in the constructor, I have this colon CLogger v1, and that calls the constructor for CLogger v1 before running any of the code for CLogger v2. And so the same here, this will call the constructor for CLogger v2, which will in turn call the constructor for CLogger v1, and they will cascade back down until reaching this code. And all I have to do here, I'm just setting the log level to log level error. So that's the default log level that I will set if you simply create this class and don't bother to set a logging level. And nothing in the destructor. And just as before, this will also call the destructor for v2, which will call the destructor for v1. You don't need to use this syntax to call the parent level destructors. And the set log level function is nothing more than taking the passed in value of log level and storing that in the member variable. And converting that log level to a string. First, I'm using the enum to string function to get that log level into one of these enum values. So that will simply return one of these strings: log level error, log level warning, log level information, and log level debug. They're all the same in that they have the first 10 characters which just say log underscore level underscore. So I also have this string substr, and that is taking the enum to string, comma 10. So I'm taking the value of this enum to string beginning at position 10 to the end of the string, which will just give me that last part of the enum. Now I'm grabbing the first character from that, again with the string substr, from position 0 for 1. So ch will contain just the first character from that. And then I'm resetting result to be just everything after that first character. So beginning from position 1 to the end of result. So result already holds just error, warning, information, or debug. I'm now just removing that first character and taking the remainder. And then I'm converting that to lowercase. So instead of returning uppercase information, I'm going to return an uppercase I followed by lowercase information. So I've got result, which holds the remainder of the string. I've got ch, which holds the first character. And then I just concatenate those. So that will return the string value of the log level. And I'm using that because that will be inside the messages. And now I have the write function. This has changed because previously it just took the message, and now it also takes a log level, or if you don't include the log level, then it will be an information. So this is where I said if the log level that you've passed into this function, so if you pass in log level debug and you've set the logging level to information, debug is greater than information. And so I say if the log level is greater than the specified logging level, then it will just return true. So it says I've been successful even though it didn't log anything. And then I'm constructing a new message by using the get log level string on that log level that was passed in, and appending a comma and then the message. So this is a comma separated file. So I'm just taking two strings here and joining them together by a comma, and that means that the message now, or this new message, is a comma separated value. And then I can simply call the clogger v2 write function, passing that new message, which will take care of all of the normal write functions for me, but the message now includes the error level or the logging level and the actual message. And that's everything for the v3 logger. I'll just do a syntax check on that. That was good. And now, as before, I will create a script to test this. Now, here's the version 3 test. In this case, I'm including logger v3 now. Declared my object type of clogger v3, new clogger v3. Same statements here. I'm setting the expert, the magic number, the file name format, and now I'm setting a logging level of information. I'm making two writes just using the default, so I'm not passing in a log level here. And then I'm making 4 more calls where I'm calling first with log level error, warning, information, and debug. And this one will not be written because debug is a higher level than information. So we've said we're only logging up to information. The debug statements will be ignored. Compile and run that. Back here I have Orchard, and now I have the log v3, USD, v3 example expert, the magic number I set, here's the CSV file, and here are the 2 default messages that went through with no level set, and so they've picked up the default level, which is information. And then here are the 3 messages for the error, the warning, and the information, and you can see the debug message is not here. So that was ignored by the logger. And now the last one, logger v4. I'm including logger v3 because I'm going to be inheriting from that. And in v4, I've already in v2 set that you could have a template for the file name. In logger v4, I'm going to allow you to set a template for the contents of the message and include headers. If we just go back to this file that we've just written, you can see that although it has the values, there is no heading here. So just like before, I'm declaring a class clogger v4, inheriting public from clogger v3. Nothing in private. In protected, I'm allowing you to specify a heading, so I'm storing the heading here, and I'm storing the format of the log messages. And just as with the file name, part of those log messages may have fixed values, so I'm just going to do a pre-format on them and store them in this log format fixed. And so I need a format fill function. It will take the format, which will be one of the formats that's passed in, and these are the arguments that you're passing to the right, which is the message and the log level. So those are the 2 things that will vary based on the input at the time you're calling for logging. Any of the other variable placeholders will vary based on some kind of environment value. And of course I'm changing log open because I'm now writing a heading. Constructor and destructor. And of course the write function will also change because I'm now using the template to write the values. And I have a set heading so that you can set the value in this heading, and also a set log format. In the constructor, just like before, I'm using clogger v3, so I'm calling the v3 constructor before I execute this code. First thing is to set heading with a default heading. So the default's going to be time, symbol, time frame, type, and message. And then the template that I would use for the default heading, which would be the time, the symbol, the period, the log level, and the message. Nothing in the destructor. So set heading is as simple as storing the heading value in that mHeading member variable. Set log format also stores the log format, but then it, as I said, does some pre-formatting into this log format fixed by calling the format fill fixed. And that's the same format fill fixed function that we had earlier, but now I'm passing the log format as the string instead of the file name as the string. So now the format fill function. And this needs to be here because I have these 2 values that are going to be passed in at call time rather than pulling in environment values. So this is overriding the format fill from v2. I still use the format fill fixed because that only uses environment values like symbol and period, but the format fill was also bringing in time and things that will change at each call. But the 2 other things that will change are the message and the log level. But I can first use the values that are in format fill, so all of those date time values can be filled in automatically using the existing function. I don't need to duplicate that, I just need to call it and I call that using clogger v3 double colon and the function name. And then I'm just using the same string replace statements on that format, but in this case I'm replacing the message placeholder and the log level placeholder with the message and the string value at the log level. And then I just return that format string. The log open changes a little. First I'm calling the standard log open from v3. Now there is no log open function in v3, but when I make this call it says I'm calling my parent, and I can put v2 or v1 here, but it will start at v3 and call log open. There is no log open function in v3, so we'll then try to find a log open function in v2 and all the way back to v1. So I'm using the immediate parent because in future, if I do create a log open in v2 or v3, then it will call that, where if I simply said v1 at this point, it would skip over those. But after that, testing if the handle is invalid, then I return, because there's nothing more that I can do because I've been unable to open that log file. And now because I want to write a heading, I check this file is ending. And that means because I've just opened the file, I've called the log open file, I've just called that, I've opened the file, and if I'm already at the end, then there's nothing in the file. So if file is ending for that file handle, then I write the heading, and that's just file write handle heading. And then I flush that to get the heading out of memory and onto the file. And that's the end of the log open changes for the v4. Now the write function changes as well. The same test here, if the log level is not greater than, or if the log level is greater than the selected logging level, just return true. I'm overriding the write function from v3, so I need to have the same condition here. And just like before, if I have an invalid handle, or if the file name has changed, then I need to reopen the log file, or open a new log file. And if I get an invalid handle after that, then I just return false. I'm setting a Boolean value result to true, and I can reset that later if anything fails from here. I'm still creating line, but I'm using format fill, and that's why I need a new write function for v4, because I'm now setting the line value based on a formatted template. So I'm using format fill, using the fixed, which is the partially parsed template, and passing the message and log level. The rest of these statements are the same. Move to the end of the file, attempt to write. If the attempt to write returns a 0, then my result is false. Else, and this else matches the file seek, so if I was unable to seek the end of the file, then I also set the value for return to false. I flush the values from memory into the file, and then just return that result. And that's the end of the v4. So by the time we get to version 4 of logging, we have included logging levels, the ability to limit which levels are logged, include the values of those levels in the log messages, and formatted strings for the file name and the contents of the logging file. Let me check the syntax on that. That worked. And let me create another script file to test that. All right, logger example v4, including logger v4. Types are clogger v4. I've changed the expert to v4 example expert and the magic number to 41234. I still have the file name format, that hasn't changed. My log level is still information. I'm setting a heading, and I'm putting local time, server time, time frame, level, and message here. So I'm logging not only the local time, but also the matching time from the server. Setting the log format. So these placeholders now match the heading. They don't have to match the heading, but it makes your file make a lot more sense. Local time and time. So these are variable values. Period will be fixed. Log level will depend on the logging message called and message. Just as before, I'm calling the default logging twice, and then I'm calling error, warning, information, and debug should not be written because I have set my logging level to information. I'll run that. Inside Orchard then we have now log v4. Symbol, expert name, magic number, here's the file. There's the heading, local time, server time, time frame, level, message. The two default messages with the default severity information, and then the error, warning, and information message, and no debug message. So that's an object-oriented approach to logging, showing 4 different levels that we can take the logging to, and in the end at version 4 we have a very flexible logging mechanism. Hope you found this useful. If you did, remember to click that like button. Next week we'll be revisiting an earlier video where I showed how you can create the on-trade event in MQL4, and I said at the time that I could capture more information. The default function in Metatrader 5 simply says that something has happened. I'm going to be showing how you can detect what has happened and get the values out of that event in Metatrader 4. If you want to see that video and any of our other videos, then subscribe. So until the next time, thank you for watching.